Welcome to Machine Tool Maniacs, the podcast where machining, fabrication, entrepreneurship, and bringing ideas to life collide. Around here, every story is a success story. I'm Matt, a second-generation manufacturer who's been in the shop since I was in diapers, learning the tools, the trade, and the people behind it all. Nearly everything in our daily lives is passed through a CNC machine. And we're here to spotlight the makers turning raw material into reality. Whether you're dreaming big or building bigger, this is your inside track to making it happen. Welcome back to the podcast. This is another episode of Machine Talk, and I have with me, once again, Will Mund. And if you don't know him by now, he is the owner of Greenlight Machinery. Say hi, Will.
Hi, how you doing today?
Good.
Good.
So
thanks for having me on, Matt.
You're welcome. Thanks for being back on. Everybody seems to like it when you're on, so
I don't know why, but I'm glad they do.
Well, I like it when you're on. We have great conversation, so
thank you.
Well, this episode I put together because Will and I found ourselves in a conversation the other day talking about machine controls, the CNC controls that you are likely to see when you're out there jumping around from one job to another or on one machine to another. You're likely to bounce amongst a variety of machine controls. And I figured this would be an interesting conversation for others to hear.
Absolutely. The thing that's funny about that conversation is that it started out talking about macro programs, because I was in the middle of building one and was having kind of a problem, and I know that you've built a couple of macro programs, and so I figured I'd call and pick your brain and see if you could see something that I didn't. So, and then it devolved into talking about different controls and things that we liked, things that we didn't like, stuff that we were seeing and experiencing with them. And it's always fun on that stuff.
And that's the important thing to remember when it comes to controls. And I'm sure anybody who's been in this field long enough and been around enough of a variety of controls, every control has its positives and every control is going to have its negatives. Some are going to have features that are just amazing, and others are going to have features that just drive you nuts. So,
and I think one of the biggest takeaways that I've had being in industry is I used to be a lot more timid when it came to getting in front of a machine that has a control that I wasn't familiar with. So the first shop I was in, they were a mishmash, right? They had Mazaks, they had Doosan's, they had a couple of Kumas, and then they had like some older Mori stuff. They had a couple Hercos. They had everything. Mm-hmm. And I was still kind of in over my head in a lot of ways. And so I didn't exploit the opportunity to learn as much as I could have on them. But I've learned over time that really the controls might have a few differences. They might call different things by a different name than another control builder, but they essentially all do the same thing.
Exactly. Well, at their core, you need to be able to load a program. Mm-hmm. You need to be able to set your work and tool offsets. Mm-hmm. And you really need to have some sort of form of cycle start and feed hold and rapid override. But I mean,
of course, you need the big red oh shit button on all of them.
Yeah, that big e-stop button.
But I had the opportunity with a couple of people I've been around in industry that they had spent time in the industry back when you still were running programs off of like punch tape, Mylar tape, or off of the magnetic tape. And I still run into machines that still have a tape reader built into the side of them.
Really? You do?
Mm-hmm. Not very often. But not last year, the year before that, I had a customer who wanted me to take a look at an old Yasnak controlled Shizuoka. And no kidding, mounted right there. The machine was in pristine condition. I mean, it still had like 98% of its paint in the machining area on this thing. All it ever machined in its life was plastic, right? So the
Okay.
machine was in incredible condition. But there, mounted to the side of the electrical uh, enclosure, was a magnetic tape reader. And I can think of one. There were two machines, and they were identical to each other that way. And then I can think of a machine up in Logan right now that a friend of mine has in his shop. It's a 1990 um, Matsura, one of the old red and white machines, and it still has a tape reader mounted on the side of it,
Wow. So
which is wild.
are these NC machines or are they still CNC? They just use the tape to store the program.
So these ones these are CNC machines. So a true NC machine hasn't been around since probably the late 70s, early 80s. And so the main difference was that the NC machine, they ran entirely off of the tape, or off of punch cards in the real early ones. And so like you didn't have a user interface where you could watch the program execute. You didn't have a lot of that stuff. It was literally, it would read the coordinate off of the tape and move to that position.
Yeah.
Whereas CNC has onboard computer, so that's when you started having displays where you could watch the program execute. And sometimes you could go in and you couldn't do it in the real early versions, but later on you got to where you could actually edit the program right on the machine. Whereas on the old NC machines, if you needed to edit the program, you had to go back and punch a whole new tape, or you had to cut out a section of the tape and put in an adjusted or edited part, and then do it that way. If it was the old punch tape kind of stuff.
Yeah. So the first CNC machine that I ever ran was a Cincinnati Millicron. It was a Sabre 750. Well, that wasn't a huge one. It was probably about a 20 mil.
Yeah. Well, but that's still, I mean, yeah, Cincinnati, even on their small machines, they were built like tanks.
Oh,
just
yeah.
good solid iron.
It was
is
solid.
what I meant, not not being a huge machine.
Yeah. And it was a CNC, but we did store the programs on tape, and we had to load them in. We had a tape reader that we rolled around on a cart, and we'd load the program through the RS-232 port on the side of it from this tape reader. And then once we were done running the program and we had updates in there, we would read it back onto a fresh tape and then store it in a cabinet that just had rolls of tapes in it. So
that's just wild, man.
I've had some experience with tape, but never an NC machine where it was just reading off the tape.
Yep. And it's funny that we talk about that, because like there's some really cool history on the development of CNC and NC machines, and like even just the development and standardization of G code. Something that I find interesting is that, and how can I put this? Like we here in the United States, a lot of times think that in very US centric terms. And so we think, oh yeah, we were the first to do this, first to do that. Or we're the ones that built all this. Well, to an extent we did, but at the same time, there were people in other countries that were also developing in parallel the same kind of technologies and whatnot. It's kind of like if you ever read about the history of calculus, we know that Sir Isaac Newton is the one that gets all the credit for calculus and whatnot. But you start reading about it, and Leibniz in Germany was also very much developing calculus at the same time. And then you have how Isaac Newton ended up kind of talking some mad crap about Leibniz and some different stuff. But it's just funny how we as humans, once we get to a certain point, we all start trying to think of the same things, and then it just becomes a race of who gets to that place first.
Yeah, and there's versions. I mean, the nuclear programs is a great example, or the space race, right?
Exactly. But there's some really cool history. The more I'm in the industry, the more I realize how much of a nerd I am for it. I saw a thing on LinkedIn a couple weeks ago where a guy linked to the history of U.S. machine tool builders. And
Mm.
so now I'm trying to find books on that, because really the US at one point in history used to be a leading manufacturer in machine tools
Oh yeah.
and machine tool technology. And then by the time we hit the mid 80s and then through the 90s, we just got decimated in terms of, we got left in the dust. We were exporting so much of our manufacturing and different things, and like Giddings and Lewis and Cincinnati Millicron and some of the big players that had been huge in the United States, either they stagnated in their technology or they got bought out by some other, multinational corporation or whatever. And it's just wild, because we can see the effects it's had on our country now, what those decisions have made.
Yeah. Pratt and Whitney
Mm-hmm.
is an example.
Yep.
Warner Swayze,
Mm-hmm.
Monarch.
Yep.
And when you see them, they're gorgeous machines. Not
Oh
only
yeah.
were they insanely well built, they are beautiful.
Yes. Like a Monarch 10 EE is still one of my dream manual machines to have in my shop. Because when they are fully restored, that Art Deco design of them, they're just beautiful. And that was a manual machine that I can't remember what their guaranteed accuracy was, but it was one of the most accurate manual machines that you could have in a tool room.
Mhm.
Like, if that you knew you were working for a serious tool room when you walked in and they just had a lineup of Monarch 10E lathes, because they were just so well built. You can actually still get a 10 EE. You can buy a rebuilt one from Monarch today, but it's like $80,000 to have it completely rebuilt. And it's like, most shops aren't going to spend $80,000 on a manual lathe.
Yeah.
They look and go, well, for 80 grand, I can have a CNC lathe that's going to, hold almost the same accuracies, but it's a lot easier for us to, produce and run and whatnot.
Speaking of Monarch, I have very vague memories as a child going into the shop that my dad worked for. They had a Monarch CNC mill that was made in the
Really?
70s. And I've looked for pictures of Monarch built CNC mills. They're extremely difficult to find.
Oh, I
But
believe it.
they had a Monarch CNC mill. And I remember as a young child being terrified of it because it had a tool chain that went all the way around the machine. And
Whoa.
so you're sitting there, your 5-year-old kid, and you see drills and slitting saws and all these cutters just hanging
Just
off this
hanging there.
machine with a guy kind of standing in the center of it on this platform. And this thing was huge.
Oh yeah.
I mean, I was probably 5 or 6, so I guess everything's pretty big when you're 5 or 6, but interesting machine. I have, like I said, I have very vague memories of it, and I would really love to find pictures of it because
I'll
it's
keep my eyes
difficult to
peeled.
find information on it.
Mm-hmm. That's like, there's a shop up in Idaho Falls I've been in, and he's got an old Boston-matic vertical machine. You ever heard of Boston-matic?
No.
Yeah, they were one that was like big in the 80s. They had their own control and stuff, and were built like the Cincinnatis. They were built like tanks, but now it's like they don't exist. Like, they're just gone.
Well, that brings up an interesting point to discuss is some of the extinct controls that you still are likely to run into if you're traveling around from shop to shop.
Mm-hmm.
And the first one I wanted to talk about was the achromatic control, which is what you were likely to find on a Cincinnati Millicron CNC.
Yep.
And I actually ran one of those. So I don't have a ton of memory about it. But you actually just, before we started this episode, had told me some interesting things about the early achromatic controls.
Oh yeah. So I don't know a lot about them. Again, they were kind of phased out by the time I got into industry, but a couple of guys I worked with when I still worked for the HAAS dealer out here, is when they were going through school for the manufacturing engineering at Weber State, there had been a Cincinnati. I can't remember if it was a turning center or if it was a mill, but it had an achromatic. And mind you, this is back in like 1988 ish, 1987, somewhere in there. And it had a legit touch screen control on it, and like not Windows based in that it was built on the Windows operating system like some controls are now, but like it had the icons and was a Windows-esque type control, which back in the 80s would have been like super high technology, especially on manufacturing equipment.
Yeah, that's interesting.
And they had that. And there was another, so Cincinnati had like two different controls. They had the achromatic, and then there was another control. I think it was called com. Hang on just a sec. I've got a note here. It was called CAMAC, CAMAC. That's another one that Cincinnati had, and that was their own control as well.
Hmm.
I think CAMAC was the original CNC control that they had, and then I think the achromatic was in the later or the higher performance control. But yeah, you'll still run into them once in a while. I know of a big double column bridge mill down in southern Utah that's a big old Cincinnati, just a beast, and it's running an achromatic control on it.
Yeah, and I'm constantly poking around looking at used machines,
Mm-hmm, mm-hmm,
and I think I saw a Cincinnati Millicron mill for
mm-hmm.
sale somewhere, not somewhere in the state of Utah.
I believe it. You know, speaking of like extinct-ish controls, another big one that you'll run into pretty regularly is Yasnak. That was built by Yaskawa Electric, and they still do, robotics. They still do servo drives and servo systems. I mean, heck, Herco and HAAS are probably two of the biggest consumers of Yaskawa servo motors in the United States,
Hmm.
because that's what 90% of their machines have on them,
Wow.
are Yasnak motors, or not Yasnak, Yaskawa. But Yasnak, I don't know exactly why they got out of the CNC control game, but it seems like about the end of the 90s, they just said, we're done. We're not playing in the CNC control world. Crazy part is though, if you've got a machine that's got a Yasnak control on it and a servo drive dies or something like that dies, you can get like 90% of them rebuilt by Yaskawa today. They will
Interesting.
refurbish it and it'll be as good as new, and you can take off and run with it.
Yeah, I know my dad had a Hitachi Siki
Mm-hmm,
in his
mm-hmm.
shop that
Great
had a
machines.
Yasnak control on it. And I've heard of some early Morisikis having Yasnaks and
Oh yeah.
Kitamura.
Yep. Kitamura had them. Hitachi Siki, Morisiki. Those were the big players that ran Yasnak a lot. Matsura had them. In fact, my friend that's got the Matsura up at his shop, it's got a Yasnak MX3 control on it. But yeah, Matsura ran a lot of them. They were really they were big with the Japanese machine builders. The couple Shizuokas I was talking about earlier, they had Yasnak controls on them.
How similar are they to the same generation of FANUC controls as far as
Um,
operation?
they have some slight differences, and it's according, especially talking with my friend, he said there's just enough difference between a Yasnak control and a FANUC control that if he's got his guys running the FANUCs a lot, that when they go to switch over to the Yasnak and run that machine, it's like they have to stop and flip a switch, and it takes them a little while to get used to setting it back up and running it and whatnot. Um, Mitsubishi and FANUC have a lot more in parallel or common to each other, to where it's not nearly as big of a jump. Yasnaks, from what I've seen and the very little that I've run them, is that you the steps to do something are in a different order than a FANUC.
Okay.
And so that's where it gets a little confusing for people, is it's like, oh, well, I do this and I push this and I do this, and then it should be set on a FANUC, versus I do this, and then this on the YASNAC. And it's kind of a different order, different setup, but still a solid performing control if you've got them.
Yeah, and they're still floating around.
Oh yeah. I run into YASNACs probably once a month doing service. I'll run into a machine that's got a YASNAC control on it.
So speaking of another machine
Mm-hmm.
brand that floats around, and I swear these things will probably get rebuilt and rebuilt and rebuilt to the end of time.
I don't mean this in a negative way. They are the cockroaches of the machine tool world.
Yeah.
Everything will be dead except for a Fadal.
That's true.
And the Hostess factory. You'll have nuclear fallout, and it'll be cockroaches, Fadal machines, and Twinkies.
Absolutely. Which actually, I didn't even realize this. I was poking around doing some research for this episode. Fadal is back up and running, I guess, as of 2014.
Yep. So a little history on that. And the only reason I know this is because I've talked with a few of the people that were involved with the resurgence. So there's a machine tool group. It's a company that owns a lot of different machine tool companies, right?
Mm-hmm.
And they're called MAG. Well, years ago, like say late 90s, early 2000s, MAG ended up buying Fadal. And then what ended up happening is to the best of my knowledge, they didn't want to keep building Fadals the way Fadals had been built. And so you'll notice that there will be some Fadal machines out there that'll say Fadal and then MAG on them, and they'll have a FANUC control. They won't have a Fadal control on them.
And I've seen those, yeah.
Yep, me too. I've worked on a couple of them, and they're a little weird, but overall, they're a FANUC controlled machine, so they're pretty vanilla stuff. But eventually, because of the way things happened and with MAG buying them and whatnot, people just didn't buy them, because a lot of why people liked the Fadal machines was for the Fadal control.
Absolutely.
They didn't sell a lot of them with the FANUC controls on them. Well, then Fadal or MAG just basically goes, we're done. We're not running this anymore. We're not doing this anymore. We're just done with Fadal. And so then a few years goes by, MAG sells off Fadal, because MAG was dealing more in the bigger machines. Like MAG used to own Giddings and Lewis, and they had bought Cincinnati Millicron at one point and different stuff. And then those got sold off to a company called FIFS, which is a French conglomerate. And like G&L and whatnot, you can still buy a quote unquote Giddings and Lewis, but it's by FIFS, right? The FIFS group. But they sold off all of the intellectual property and the name and everything of Fadal to another company. So then that just kind of floats around, doesn't go anywhere. And then somebody eventually picks up that property and starts wanting to bring import machines into the US under the Fadal name and try and revive the brand, because they see how many Fadals are out there and go, hey, we can, keep this going, or we can kind of revive this. So you can actually buy a brand new Fadal today, but it doesn't have a true Fadal control on it. It's actually a Taiwanese control called a Centec that they've reworked to be able to do some of the same unique things that Fadal had. And everything I've seen on these new Fadals is they're pretty solid machines. Like they have boxway machines. They're robust, and they build them in Taiwan, import them, and the Taiwanese build excellent machines. So
they even have a 5-axis machine. I was on their website the other day.
Yep, exactly. And the Centec control, we don't know it very well over here in the US, because we're primarily FANUC, Mitsubishi. Siemens is making a lot of inroads. Heidenhain is coming in a lot more, especially on 5-axis machines. But the Centec is a Taiwanese control, and it is really popular over in Asia. Um, Fun little tidbit: if you know of anybody that runs the Ganesh slash Genturn CS machines, they're a guide bushingless uh, sliding headstock turning center. They're really popular for a lot of small parts turning, like the 32 CS, the 36 CS. That is actually built using a Centec control,
Okay.
and so they're pretty solid, pretty reliable units. Um, but yeah, that's what the new Fidal control is running, is a Centec.
Yeah. The story of Fadal is so interesting to me because as far as the machine tool world is concerned, it was so iconic in its
Yep.
time. I mean, it's almost like Harley Davidson going
Yeah.
belly up. It-
Have you ever watched the movie Short Circuit?
yeah, I have.
The one with Johnny Five, the
Yeah.
robot.
Uh-huh.
If you watch the opening sequence, the opening title sequence of that movie, it has Moto Man Robotics, which is Yaskawa, and it has Fadal controls and Fadal machines that it shows. Like you go look up the opening title sequence for
I'll have to
Short Circuit,
Yeah, I'll have to go
and
back
that's
and
what
watch
it
it.
is. I watched it as a kid, never knew anything about it. Then I watched it again a few years ago as an adult, and I about crapped because it's like, oh, I know what machine that is. Oh, I know what machine that is. Oh, I'm having one of those nerd out fests, going,
I've
oh, I know which that is.
I've admittedly had those in my life too. Actually, one of the episodes, I don't know if it was the first Iron Man episode with
The
Robert
movie.
Downey Jr.
Mm-hmm.
I'm pretty sure I remember there being a one of the Hardinge Bridgeport
Mm-hmm.
VMCs
Mm-hmm. Mm-hmm.
in
Mm-hmm.
that movie, and I
Yes.
recognized it. And I was like, "Look!" Of course, I'm telling everybody around me, and nobody really cares. But
Yep, exactly. But those of us that are inclined toward machines were like, that's so cool.
yeah, we see something and we get all pumped. So, speaking of Fadal lineage,
Mm-hmm.
we can move into some current players and HAAS. They
Mm-hmm.
have their beginnings in
Yep.
Fadal because, as far as I understand,
Mm-hmm.
HAAS got their start by building rotary tables for Fadal. Is that correct?
I don't know for sure if it was for Fadal. I know one of the big things for that got Haas started was Gene Haas. If I'm remembering correctly, Gene Haas had a machine shop and had regular Bridgeport mills and wanted an NC type indexer. Like he wanted to have a rotary indexer for his Bridgeport machines. And I don't know who he talked to, or he had friends that knew some of the stuff about like building a servo control unit or whatever. But that's how they got started, was building a rotary indexer that you could put on your Bridgeport. And it had some kind of a switch to where you'd write your program, the position you wanted it to move to. And then when you pulled the handle down, you could drill your hole. And then when it came back up, it hit this switch and told the control unit to index to the next position.
Hmm.
And so then it would do that. It would index, and then you could drill your next hole. Funny little tidbit: Haas and Fadal, when they were both in, let's see, what the heck is the city in California? It's not Rancho Cucamonga. It was the place where I still run into Haas machines that have it on the machine data plate, but it was where they were located before they moved down to Oxnard. But they actually shared a parking lot. Like a couple of these great big concrete tilt-up buildings had a common parking lot between them, and FANUC was in one building, or not FANUC, Haas was in one building, and Fadal was in the other building.
Hmm.
And apparently, Gene Haas, being who Gene Haas is and super competitive, he changed something about the way when they would ship them or whatever, where they would all the machines would get stacked in this parking lot, basically to do like psychological warfare on Fadal, going, yeah, we're building more machines than Fadal is, and we're gonna, like totally dominate them, and blah 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 blah. That kind of stuff.
Well,
But
it worked.
it did, but I don't think I'd be speaking out of turn and thinking that mechanically, I think the Fadals were better built than a lot of the newer HAAS machines are. But that doesn't matter now, right?
Yeah, it doesn't matter. It's all bygones at this point.
Yep.
So as far as the HAAS control,
Mm-hmm.
I'm sure they engineered it after something,
Yep.
right? Either a FANUC or a YASNAC or maybe a Fadal control. Where do you think its original design was based off of?
From the earliest HAAS controls that I've run and worked on, I would say they have the most in common with a FANUC.
Okay.
And that makes sense. I mean, FANUC is really, I hate to say it, but they are the big dog on campus.
Oh, yeah.
If I remember right, it's like 58% of all machine tools in the world that are built using a FANUC control.
Okay.
So, I mean, they are the big dog on campus when it comes to that stuff. But Siemens and Mitsubishi are really making some inroads in there and taking over, because just like a lot of big players, FANUCs kind of got complacent and went, nah, everybody uses us. We don't need to change. We don't need to adapt. Whereas these newer controls are trying to adapt and make it more user-friendly. I say user-friendly. Some of it is just more, ooh, shiny buttons. Look at this kind of a thing. But that gets people's attention, especially when they're accustomed to like their smartphones and whatnot.
Well, especially picture based, right?
Yes.
And that's a big struggle with Japanese stuff in general.
Mm-hmm.
I do not think the Japanese like making things that are picture based, and maybe it's just
which is wild for a country that does anime and manga.
Yeah, exactly. So, what percentage of HAAS code is shared with FANUC?
In reality, other than M codes, because M codes are more builder specific, but G code, you can literally take a FANUC OI post processor, you dump it out, and you change from a 2-line threading cycle on the lathes to make it a single line threading cycle, and it'll run on a HAAS.
Yeah.
HAAS conforms really well to the ISO standard or the EIA standard for G code. And so like they do good. Mitsubishi really is very, very much that same way. I haven't messed too much with Siemens. I know that they have a certain amount of compatibility and carryover there, but they're a little different because they conform to the DIN standard, which is the German standard for G code, which is a little bit different, but still pretty much the same on all the major points.
Yes.
So
one interesting thing I'm curious about suddenly, do HAAS controls, and and obviously we bring up HAAS first because it's kind of America's machine.
It's 46% market share in the United States is HAAS.
Yeah.
So basically 4 out of every 10 machine tools sold in the United States are HAAS machines.
Probably every other machine that we're going to bring up, or control at least, is running metric on the back end.
Yes.
Do HAAS controls run metric on the back end as well?
All the next gens, everything's in metric on the backside. So all of your machine parameters, like tool change offsets, everything that's in the backside that the regular user isn't going to be messing with, that's all metric.
Interesting. And is that because they're using the Yaskawa servos and drives?
Nope. And HAAS doesn't use Yaskawa drives. They just use Yaskawa motors. HAAS actually has their own servo amps that they run that drive the motors.
Okay.
If I'm being 100% accurate, technically the models of Yaskawa motors that HAAS uses are specific to HAAS. So HAAS does that. What they'll do is they will find a off-the-shelf Yasnak part, or like Pepperell Fuchs for proximity switches. They will find an off-the-shelf part that does most of what they want it to do. Then they will go to the manufacturer, and because they've got the buying horsepower to do it, they will say, we want this model, but we want this one little change made to it. And we're willing to buy this many units from you. And usually the manufacturer will go, okay, here you go. Bam, done. Well, what that does is it does two things. One is it makes it so that way HAAS gets the parts that they want to behave the way they want them to behave. But what it also does is it makes it to where that specific part number is specific to HAAS, and they own the IP of it or the design of it. And so if you go as a third party and go to the manufacturer and say, hey, I've got this part, it's this part number, I'd like to get a replacement, they'll go, no, you can't. If you want that, you have to go to HAAS, because that is a design specific to them. And so either we have to get written permission from them that you can get it from us, or you have to go directly to them. And
interesting. So it's their way of keeping the manufacturing costs low, because it's something that's already getting manufactured, but just changing it minimally enough that they can control the price.
Yep.
Well, you gotta hand it to them.
And it's a smart way of doing it. It's kind of like what John Deere does, makes it to where, like, for years, John Deere had their own fasteners. If you broke a bolt in a John Deere tractor, you had to go to John Deere and get it, because it was not a standard size and thread. I didn't
even know that.
Yep. It was a way of forcing people to have to come back to John Deere to buy parts. Caterpillar, on the other hand, they're like, no, we're going to use off the shelf stuff, and we'll sell parts to whoever, because at the end of the day, we want to keep our machines in the field.
Yeah. So interesting. Well, before we move on from HAAS, I think it's worth bringing up another interesting thing that you mentioned once upon a time.
Oh, to answer your question, sorry.
Go ahead.
About why they're running metric. Part of it is because of their software development team for their machines is actually Indian. Dots, not feathers. They're based from India, the software guys. And so they are much more familiar with metric measurements, that kind of stuff. So they build all that in metric. Plus, if we're being completely honest, the metric system is, I forget what the number is. I think it's like 44% more, quote unquote, more accurate than the imperial is.
Well, because 4 decimal places is a lot smaller than 4 decimal places on
1/1000th of a millimeter is like 40 millionths in the inch in the imperial system. So, and I'm not gonna spark the debate which one's better or whatever. I jump back and forth between both of them, and am pretty well fluent in both of them, so it doesn't really bother me one way or the other.
Well, I imagine if you're building a machine and you're trying to get things to communicate, and it's probably a lot easier to utilize the metric system.
Yep, exactly. So,
one interesting thing that you had brought up previously that I kind of thought was brilliant was you brought up how smart it would be if HAAS started putting their controls on other machine tool builders' machines. And I just thought, at least for the United States, might not be as big of a deal in other countries, but I know here, a lot of times people continue to buy HAAS machines knowing that they're not as accurate, knowing that they're not as rigid, knowing that they can't push them nearly as hard as they could push a Japanese or some other built counterpart, but they buy them because they don't want to retrain people to use other controls. They like the control so much. And I just thought that was, to be honest, I thought that was brilliant.
Yep. I know guys, there's a couple of guys that I met that were customers, and one of them actually had the HAAS logo tattooed on his forearm. Like,
I believe it.
That man, he bled HAAS on stuff. But talking with him, he's like, I've got this great big Yamasaki bridge mill. And he says, and I hate running it. He's like, I wish that you could put a HAAS control over onto the machine. And he said this to me like 10 years ago. And my brain has just percolated on that, and watching where the industry's going, and knowing there's a shop up in Idaho that I went into, and it was when I was selling Herco machines, and they're like, it seems like these Hercos are really good machines, but everybody around here, I can go to the tech college or whatever. Everybody around here knows how to run a HAAS, and I don't want to have to spend the time training them on something else. And that got me thinking, is it's like, if HAAS really wanted to, I say this, not being the guy that's running a multi-billion-dollar company, so take it
Yeah.
for what it's worth, right?
Or having an F1 racing team.
Yeah, or a NASCAR team or anything like that. He definitely has FU money at this point in his life. But I think if they really wanted to have HAAS continue on and be able to really jump into the next level, as it were, as a company, I genuinely think they would, if they were smart, they would quit building machines altogether. Like, still build parts to support the machines they have out there, right? Not leave people high and dry. But I think that if they dump their time and their resources into building the HAAS control to make it where it'll go on any other machine, make it so third parties could, go out and retrofit HAAS controls onto other machines or whatever, I think they could really give the other control builders a run for their money.
Oh, yeah.
Especially here in the US market. I think they could really do some damage to the other companies, because I will give HAAS 100% credit here, is that their control is very user friendly and very easy to learn how to use.
Yeah. And maybe even just keep building machines, because in their category, they build a great machine.
Yeah.
But there's just, if you're cutting Inconel all the time or hard materials, and a lot of this.
HAAS machine is not what you want to do that.
No, it's not. It's not.
But boy, if you could take say an old Mori SV, 580 vertical, or 5100 vertical or whatever, and put the HAAS control on there. Oh, I think that'd be a heck of a machine to compete against.
Yeah, or like a Makino horizontal.
Oh, criminy. I can't even imagine a Makino horizontal with a HAAS control.
Yeah.
Just in terms of setup and usage. But they to be able to pull off what Makino pulls off with a FANUC control, HAAS would have to dump some serious money into their controls. Interesting little side note. So FANUC controls, FANUC originally started out as a division of Fujitsu. And so, like, think hard drives, printers, stuff like that. That company,
okay,
right?
yeah.
Fujitsu Electric, if I remember right, is what their name originally was. So once they developed the CNC control under FANUC, Makino Milling Machine Company was the first one to get a FANUC control.
Really?
Yep. So you will never see a Mitsubishi or any other brand of control on a Makino. It is FANUC, and that is it.
I didn't know that.
Mm-hmm. Yep. But Makino and FANUC are so closely tied that, like the high-speed machining algorithm, the AICC that FANUC controls run, was developed partially in conjunction with Makino. So Makino has their high-speed machining stuff called super geometric intelligence. And what I do know, I don't know many details on it. I don't want to be, putting false info out there, but my understanding is that when Makino was developing their SGI system, they worked hand in hand with FANUC to develop that, and they shared technology back and forth to where the FANUC AICC high-speed machining algorithm and the Makino Supergeometric Intelligence have some common threads in them, some common ground in them.
Okay.
So anyway, sorry, just a little interesting tidbit.
No, I mean, that's perfect transition into FANUC.
Mm-hmm. So FANUC, they started out in Japan in like 1955 as a part of Fujitsu, and it actually, I've got the acronym here. This right here would spark a debate because I'm saying FANUC, but then other people say FANUC,
Yeah, I've heard
and
them both.
even from the FANUC guys, I've heard it. They can't decide how it's pronounced. But FANUC actually stands for, it's an acronym for Fuji Automatic Numerical Control, right? And me, I'm going, okay, Fuji. So automatic, numerical, new. So FANUC is the way that I come up with it.
Okay.
But yeah, they started out, it was part of Fujitsu. Eventually, they got enough movement that Fujitsu spun them off as their own company. And so they focus on they've got 3 lines or 3 divisions. They've got the CNC controls part. They have the robo machine part, which is like robo drills, their their drill tap machines, and then like their EDMs and stuff. And then they have the robotics division. And the history of FANUC and who they've partnered up with over the years to develop technology and to get their stuff into different countries and into different industries is wild in and of itself. So for a time, like FANUC was partnered up with General Electric to get their NC controls out there more in the world. They partnered up with General Motors in developing the robotics systems to be able to bring robotics into automotive automation and manufacturing. Like it's pretty cool. I will give the people that run FANUC a lot of credit, is that they are pretty sharp in who they partner with and how they do stuff.
Well, like you brought up before, they dominate the globe, and
Yep,
anybody who's in this industry knows FANUC.
yep, yep. But again, they kind of have sat back on their laurels in some ways to where, they really, I think it's just the user interface and like how to get to where you want to get to in the FANUC control. But then again, the FANUC control is, I would argue, in certain circumstances, is one of the most powerful controls out there, in that it's so flexible. Like, really, the only other CNC machine control that can do what the FANUCs do is Siemens, in terms of it's not just for CNC machines. Like, that's a nice spin-off and it can do that. But originally it's all about automation. So you can go into, a friend of mine used to work in a paper plant in Oklahoma, and they did like toilet paper. And we're talking these great big, huge, like 400 yard long machines to process all of the paper and to be able to create toilet tissue, and has all these different tensioners and all this different stuff, and it's all run off of FANUC. It's not even a CNC machine.
Do they look just like a regular FANUC control you see on the side of a
Yep.
CNC machine?
Yep. Same screen, same, they might have some differences on the control panel because you're not running a CNC machine, but essentially navigating around, finding parameters, all that stuff is the same across the board.
Interesting.
And I know Siemens does that. Like, a friend of mine used to work for now it's Northrop Grumman, but they had these great big machines that they built that weren't even like CNC machines. They were for producing something, but it was all automated off of Siemens controls. So,
yeah.
And really, out of all the other CNC machine controls I know of, is that I guess Mitsubishi might be in that same category. But
I can see that probably.
Yeah, I can see Mitsubishi doing that, just because they also do PLCs and a lot of other stuff. But yeah, like Mitsubishi has their factory automation, FANUC has theirs, Siemens has theirs, but like Mazak, Okuma, Heidenhain, Fagor, those are all very much CNC machine specific.
They're dedicated to what they do.
Yes. And really, in a lot of ways, they do it very, very well.
Yes.
So,
Well, I guess we
sorry.
can move on to the Siemens.
Yeah.
So Siemens is a German-built control.
Yep.
Siemens is actually, I think, a large chunk of Siemens is owned by Mitsubishi, coincidentally.
Really?
Yeah.
Didn't know that.
I learned that fairly recently.
That's interesting. Now I want to dig into that and find out more, because that kind of surprises me.
I
But
was surprised to find that out as well.
but then I guess it shouldn't surprise me too much, because they have so much overlap in industries outside of machine tools, like when it comes to electrical components, even like high voltage transformers for power grid stuff. Mitsubishi does a lot of stuff like that. Mitsubishi Electric and Mitsubishi Heavy Industries, and then Siemens, they are all over that stuff.
Yes. And I don't know if, I'm sure there's components, right? Because they, like you say, they have subsidiaries, so to speak.
Yeah. Yep.
So I don't know exactly which components are shared or if it's the whole kit and caboodle. But I found that out recently.
It's really
Anyways, cool. I happen to be running some DMG Mori machines right now that have Siemens controls on them. So I'm getting quite well acquainted with the Siemens interface, and I like
what
it.
What are some things that you're liking?
You know, the way they do, they have a page where you can just, and I might not, obviously there's the Celos interface on it. So it's difficult for me to distinguish, right? Hey, this is a Siemens thing versus this is a Celos thing. But the way that they do a lot of their 5-axis and their tool center point control, they use, it's a term, it's called Traori, is their tool center point control. And then,
I think that is a Siemens specific thing.
I know for sure that's a Siemens specific thing, because I did briefly run an 840D that was on a Chiron, and I remember Traori being on that as well.
That's another cool machine, the Chiron machines.
Oh yeah, and this thing was it was a bar fed. It was like a Williman, so it was a bar fed. So it's like 5-axis
a bar fed mill. Yep. That's cool.
And it had a little vise that could come over and pick off your part, so you could do full 6-sided machining.
Oh, now that's sweet. So it would truly be a one and done kind of setup thing.
It could, yes.
That's cool. That's very cool.
So there's a lot of things I like about the Siemens. One thing I do notice, though, about the Siemens, and this is just kind of seems to be the standard for German-built stuff versus Japanese-built stuff, it's not as robust. So if you just let it sit for long periods of time, static, it'll kind of just forget how to communicate with itself. You'll have to shut it all the way down and restart it back up. So there's a lot of communication type stuff that we run into. There's also a lot of going on in these particular machines. So I don't know if I can blame Siemens. I mean, these machines have 500 tool changers. They have pallet pulls. Whoa. They have RFID chips going on inside of them. They're insane. So
that's nuts. Well, and what I've seen on those Mori, on those big freaking tool changers and pallet changers, is that they have their own controller just for that. We'll call it a module. So like the tool changer module, it's got its own little control system in there. And then that control talks to the actual main machine control, if I understand the architecture.
Yes,
correctly.
And that's exactly what's going on here. So there is a separate control on the back of the machine for the tool rack, and then there's another control for the pallet pull. And the pallet pull's got to communicate with, in this instance, 4 other machines. So there's a lot going on.
Absolutely. And like you said, that might not necessarily be a Siemens thing. That might just be this particular machine configuration and the way that DMG Mori has designed everything to work together.
Yes.
Mhm.
Yeah. So do you have a lot of experience with Siemens controls being out in the field?
I have very little. I've worked on a couple of machines that have Siemens controls, and they seem pretty well thought out. Something interesting is that I think Siemens, when they designed their CNC controls, they when they designed them is to be able to run regular G code, but then they also have some conversational stuff built in that's pretty potent,
Oh,
pretty
yeah.
powerful.
And that's another thing that's really cool is the way you can edit CAN cycles just right on the screen.
Yep.
You can, and they do a lot of graphical stuff too,
Yes.
which is, once again, I'm not 100% sure if this is a Celos thing or if it's the Siemens, but you can open up a drill cycle and you can just edit it line by line. And there's a little picture that updates it as you edit it. So it'll show you what part of that cycle, hey, this is your retract plane. This is your pec depth. So it's very user friendly in that aspect.
And that's something that I like about the Siemens. It's very German, and I think that's part of why I like it is because the Germans, they take their like machining, they take their manufacturing stuff really seriously.
Oh yeah.
And they, when they train guys, they train them to not only know how to use G&M code and how to do all that stuff, but they teach them a lot of the engineering behind it, and they teach them how to do conversational. So they're totally self-sufficient. They can start from beginning to end. So if you're going through an apprenticeship over in Germany as a machinist, you're going to know how to do everything on making these parts.
And I think their 5-axis technology is probably them and Heidenhain are probably some of the best. I mean, you even see players like DN, they're putting Siemens controls now on their 5-axis machines.
Leadwell and Feeler, if you need full simultaneous 5, they're putting Siemens controls on them too.
Really?
Because they are just a very, very capable control. I know for a time they were doing Heidenhains as well. I'm not sure what happened there, whether it's a pricing thing or availability thing or whatever, but they're doing more Siemens controls for their 5-axis stuff, which, you put a Siemens control with the 5-axis capabilities that has, and then you put it with one of the Korean or Japanese builders, so you've got that high mechanical reliability and whatnot. That'd be a pretty kick-ass machine.
Yeah, good combination for sure.
Yeah, very good combo.
Kind of like I guess they were a little different, but a De Tomaso Pantera. Remember that car?
Oh, yeah.
It was like an Italian-built body, an American engine, and a German transaxle.
Yep. Or my dream truck was to have the Cummins engine, the Allison transmission, put on a Ford frame with a Ford body. So you got like the main components of all of them, because in my mind, that was like one of the most well-built, that would be one of the most well-built, reliable, and powerful trucks that you could have.
Yeah. Thank you for tuning in to the first half of this episode of Machine Talk. Be sure to tune in next week, where Will and I finish our conversation up. Don't forget to subscribe and rate this podcast.